Anybody? What's a nematode, David? A problem. I like that. That was one of our answers from earlier this morning. Yes, it is a problem. What they are they're semi-microscopic roundworms. They kind of look like earthworms. They're not related really, but microscopic. So the plant parasitic nematodes are the ones that are going to be going after a crop. What they do, vast majority of them, they use the structure in their mouth. It's called a stylet. It's like a hypodermic needle. It's able to insert that into a susceptible plant and burrow its way in, at least with their southern root knot nematode. That's how it works. The nematodes get in, and this is the same for a lot of the different species. They get in, they establish a feeding site, they start to lay eggs, whether it's in an egg mass attached to the roots or actually within the roots, depends on the species. And then the nematode eggs start to hatch, and then you get more and higher and higher and higher populations of your nematodes. So that's kind of how the nematodes, the biology of them works. The nematodes that we're actually dealing with here in Louisiana are the southern root knot nematode, and I'm going to hand out a couple little samples we have here to look at. But our southern root knot nematode, that's Meloidogyne incognita, it gets its name from the root knots it causes. And you're going to see that in a second. There are these swellings in the root system. So the nematode just kind of got wet earlier this morning, but you can kind of see these little, the red squiggles in there. So this is a Beauregard, and this is the Guava root knot nematode, an invasive pest I'll get into in a minute. At 7 days, it gets into the root system, and then here's a cross section. They start to expand and swell up and establish a feeding site. As they do that, these aren't pickles, these are tomato roots. These are some severely galled up tomato roots. So I'm going to put these right here and kind of pass it through. I've got, here's actual sweet potato, being a sweet potato field day. Take a look at it, look at the galling on the root system. This is very characteristic of the southern root knot nematode. And here's a tomato plant that you guys can take a look at. So see if you can just see those spherical galls on the root system. There's a nematode in there. Okay, so the southern root knot nematode. We did a 3-year survey. The Sweet Potato Commission funded us for that, which is fantastic. We were able to take a look at a whole bunch of different sites. Merle helped me out on that a lot, so thank you. We got to a lot of different sweet potato fields, and we got a good sense of which plant parasitic nematodes are out there and which ones are probably causing problems. I can't remember the exact number of sites, but from the number we had, about 20% of them had the southern root knot nematode that I was just talking about, the little sample that's getting handed around. That nematode is obviously a problem. You can see it, the deformation of the roots that it causes. Well, that's what you guys are trying to market as sweet potato growers. So not only does it decrease the overall amount of yield, it decreases the markability of the yield that you do get. So that's the southern root knot nematode. We have another one that you may have heard of called the Guava root knot nematode. So this was a recent introduction. It's not a nematode that we knew of here in Louisiana, and it was actually introduced before I started here at LSU AgCenter. So back, I think it was in 2018, some contaminated sweet potato roots from North Carolina made their way up to Morehouse Parish and were bedded. Luckily, LDAF enacted on this, and they've fumigated that field. We've done quite a few different management tactics, and it seems to have worked, so we're good on that end. But we started to take a look and wonder, has this nematode pest already established? Why is it an issue? I forgot to get to that part. Like the southern root knot nematode, we have resistant varieties. I have some of them listed here, and I'll go through them in a minute. Guava root knot nematode gets through that resistance. The resistance does not protect you against the guava root knot nematode. So we're back to square one in terms of management tactics. Same with the nematicides. We didn't know which ones worked. We didn't know which crop rotations could be used. Didn't know which winter cover crops could be used. So that was a lot of the research that we did when I first arrived here, trying to establish a couple different tools that we could have in our belt in case this does establish, the nematode does establish. So that was the guava root knot nematode. We didn't find it in any of the fields that we sampled over these past 3 years. So what this suggests is that we were at the initial stages of infestation. You can't get sweet potato roots from sweet potato tubers or storage roots from out of state, seed material from out of state. Now it's all within, and I think this has been huge in preventing the establishment of our guava root knot nematode here in Louisiana. So we're in good shape, and we're starting to develop a lot of management tactics. The third nematode is, our survey shed a lot of light on this one, the Reniform Nematode. Reniform Nematode does not produce that galling that you guys see there, but it does reduce your yields. We found the Reniform Nematode, depending on the year, between 80 or 95% of the fields. I think one year we had 98% of the fields had Reniform, and almost every single field, the population densities were well above the established damage threshold for sweet potato. So it's causing problems here, and we don't have a lot of management tactics. Varieties, we really have no sweet potato varieties that we know of that are resistant to the Reniform nematode. So that's something in the future I want to start taking a look at. Nematicides, there hasn't been nearly as much work, so we're starting to develop those. So we're not nearly as advanced in how to manage the Reniform nematode as we are with our southern root knot nematode. Okay, so that's our 3 nematode species primarily that we're managing. How do we manage them? And I've talked a little bit about this already. One of our best tools is resistant varieties, and if you have a chance, you can come take a picture of this. I have a chart that shows the main commercial sweet potato varieties and their susceptibility to the southern root knot nematode. We have some tactics. Most of the varieties that we grow here in Louisiana, Beauregard, Orleans, highly susceptible. You'll notice that I don't have Guava root knot nematode listed on there. Well, as I mentioned, the Guava root knot nematode is able to get through the resistance for southern root knot nematode. But one thing that has been found is Jewel and Murasaki. They appear to be resistant, highly resistant to the Guava root knot nematode. So resistance exists to that nematode in sweet potato. Okay, so, and then Reniform nematode, again, that's another one we really don't know. I think I already mentioned that. We really don't know. I've had to do this speech twice. We really don't know which varieties are, we don't know of any varieties resistant to Reniform. Okay, so that's the varieties. So great management tool. Another one, if you can't use those, so for Reniform, for instance, nematicides. And with sweet potato production, you guys are in a pretty good spot in that you have a vast array of nematicides available and registered for use. You have some of the older compounds, some of these granular nematicides, AgLogic. Trying to think what other ones you got on here. I have a whole list, and please come up here and take a picture. MoCap, actually AgLogic's not on there. It is on there, there we go. Vidate, another one of the older chemistries. That's not a granular, that's a chemical one that you can do in furrow. And then we also have a lot of these newer chemistries that we've been taking a look at. So in 2021, we did a trial using vellum. It's a newer liquid nematicide. We did 3 trials last year where we put it out. All 3 experiments, we had really good suppression of the Reniform nematode and a trend towards an increase in yield. So we really thought we were on to something that year. We did it again this year. Obviously the year's not done, but we did do our mid-season sampling, and for whatever reason this year, we're not really seeing that suppression of the Reniform nematode. So the point I'm trying to get at, and we've seen this, actually I've seen this in all sorts of trials that I've planted all over the country, even Florida and British Columbia. Nematicides is kind of hit or miss. They're not like the varieties where you have that established genetics where it's probably going to work most times. There's a lot of factors that influence the efficacy of nematicides: soil texture, your environment, so on. You can think of anything. It probably will affect the efficacy. So something to keep in mind if that's the management approach you're going to go through. Other great tools have it winter cover crops. We've been taking a look at that. And actually I'm going to back up. With the nematicides, we started to take a look at that for the Guava root knot nematode and how to manage it. We can't do it in a field. We've done some greenhouse experiments, and it appears the Guava root knot nematode is pretty sensitive to nematicides. So I think we're going to be in good shape for chemical control. Cover crops, that's another great rotation, or winter cover crops. So, you know, the idea is that a lot of these weeds that can establish in your field in the winter are hosts to various nematode species that are out there. So they act as what's called a green bridge. You have your nematode reproducing on your sweet potato plant. You finish your crop, well, then you get some weeds established in your field. Well, those nematodes can go onto those weeds and hang out there and persist and reproduce, maintain their populations high. And then when you get to spring to go plant your next sweet potato crop or whatever you plan on planting, you're planting into a high density of nematodes. How do you prevent that? Throw a non-host into the rotation. You know, we've been taking a look at some of these winter cover crops, and we've been looking at their susceptibility to Reniform, southern root knot nematode, and even the Guava root knot nematode. And one of them that's looking pretty good is the cereal rye, the winter rye. Pretty poor host for all 3. So that could be a pretty cool management tactic between seasons. Rotation crops, that's another one, and that actually has been utilized at the Morehouse Parish site where the Guava root knot nematode was introduced. My postdoc, Dr. Santos Resende, where is she? I think she's over there. Yeah. She did a lot of the work screening for different, you know, the susceptibility of different rotation crops, and she found that corn seemed to be a very poor host. So in the site that it was contaminated with guava, we fumigated it over quite a few years, and we put some corn in there. We didn't see any nematode reproduction on that corn. So again, we're starting to get towards some good management tactics. And I think that's it for my management that I wanted to talk about. Now I want to shift themes to a new project that we've kicked off and we've been doing for. Yeah.
You didn't mention anything about fumigation.
I didn't. No.
Or nematode.
Or what? Sorry, Nimitz? Nimitz. Okay. You want me to talk about those a little bit? Okay, so soil fumigation, you guys probably know what that one is. So you're pumping a fumigant in the ground, a chemical that's going to volatilize and kill everything in the soil in theory. There's been quite a bit of work on those elsewhere. We've been playing with them here, and a lot of the work actually before I even started at LSU AgCenter, we're looking at, we haven't had quite as good efficacy with the soil fumigants here in Louisiana as we've seen in other states. I used to work on soil fumigants a lot in Florida in strawberry production and tomato. They work fantastic, but I think a lot of it's to do with the production system. We're on raised plastic beds down in Florida, so when we put that chemical in, it's getting trapped under the plastic and you're keeping it there where it needs to be, and you're getting that control of pests. We've been playing around with it here in Louisiana, and we don't tarp. We're just putting fumigant into the row and hoping for the best. Other thing is the soil texture. You probably noticed this is some heavy soil, well, relatively heavy soil. We have much heavier down where I live in Baton Rouge. Florida, it was all beach sand. So fumigants work great in those sandy soils, where these heavier soils, you're not going to get that dispersion of the fumigant. So we actually haven't had a lot of success with the fumigants here in the Louisiana sweet potato, at least since I've been here. Other thing, there's a lot of concern. Nobody wants to work with fumigants. I don't like to put on a full hazmat suit and go out there and fumigate when it's 100 Fahrenheit. It's unpleasant. We do it, but it's unpleasant. So that's where a lot of these chemical companies are moving towards what we call the next generation nematicides. And that's something I've been working on for quite a number of years now. These newer nematicides like Vellum, like Nimitz that was mentioned, like Celebro that's coming out in January according to the company, if you trust them, because they've been saying that every year for 5 years to me now. These newer nematicides, they're much safer. They don't have that skull and crossbones warning label. Put on some gloves, put on some glasses, you'll probably be all right. So they're safer. We think they're safer for the environment. That's a lot of the work that my master's student, Caleb, who must be over there now, he was taking a look at that, comparing fumigants, their impact on soil health relative to some of these newer chemistries. And what we thought is the newer chemistries would be safer. Actually, the results from a study are suggesting it didn't really matter, at least here in Louisiana. This is kind of interesting. Nimitz. Nimitz is another one. That's one of these newer generation, next generation nematicides, if you like to call it. One problem with Nimitz, one of the problems is it's phytotoxic. So you're going to have wait it's like a fumigant. When you apply it, you can't plant right into the field. Usually, I think the label says about 5 days pre-plant application. Other issue with Nimitz is the regulatory issues with it being shipped to different markets. My understanding is the European market does not accept sweet potatoes that have Nimitz. And someone else can maybe confirm that for me, but that's another concern with it. Does that answer your question? Good. Any other questions before I move on to my next portion? Okay. So the one thing the next portion I want to go through is a really big new project, and some of my collaborators are here. Scott's one of them, actually, from California. This is a USDA NIFA project from the Specialty Crop Research Initiative. We were able to secure $5 million to develop Guava root knot nematode resistant varieties. And I don't mean me, I mean as a group nationally. So if you take a look, I think it's the far right, I have a list of all of our collaborators here, not the actual names, but the institutions. So we're working with USDA, North Carolina State University, University of California, Tennessee, Mississippi State, and us here at LSU. So it's a giant national effort, and we're making some really good progress for the development of Guava root knot nematode management strategies. So we've named our projects, and we have a logo for it up here, Sweet Armor, and that's an acronym. What that stands for is Sweet Potato Advanced Resistance and Management for Root Knot Nematode. What it suggests is we're going to develop management strategies for the root knot nematode, not just Guava, but continuing with the southern root knot nematode management as well. So with this project, we have quite a few different objectives. The first objective is developing cultural management practices. So I mentioned quite a few, and a lot of the work we've done here in Louisiana looking at cover crops, rotation crops, different nematicides. I'm restricted here in Louisiana in that I don't have any Guava root knot nematode fields I can do field research at. I'm definitely not going to go inoculate a field here. That's a good way to lose my job. So a lot of this work needs to be done at North Carolina State University, and that's what we're doing. So they have quite a lot of fields up there that are infested with Guava root knot nematode. Lots of space to do this kind of work. So my collaborator, Adrienne Gorney, she's a nematologist up there. She's taking the lead on this. Okay, the second objective is more getting at the resistance, developing sweet potato varieties with resistance to guava and southern root knot nematode. This one's more or less spearheaded by my lab. What we're doing is we're taking a look at the mechanisms of resistance. So back up a bit. We already have resistance. I mentioned that. Jewel's resistant to guava root knot nematode. Murasaki's resistant to guava root knot nematode. But those aren't the varieties that we want to grow. So what we're doing is, LSU breeding program as well as the other breeding programs around the nation, we're developing newer varieties that have resistance to both these nematodes. So just this past year, I've been working with Don Labonte. I'm sure you heard him talk earlier this morning about some of the work we've been doing. We've been screening various genotypes. For instance, this year we took a look at 30 from a cross that had a resistant parent. And of those 30, 8 of them had guava root knot nematode resistance. So we're able to get that resistance into the varieties. Now it's just a matter of actually developing a commercial variety that can be released. And Don, you can talk with Don about that. So that's one aspect. We have the varieties, but why are they resistant? We don't just want to tell you that you have a resistant variety. We want to say the mechanism. So that's what my lab is primarily working on. What is it about the varieties that makes them resistant? Is it that they're not attracted to the roots? These little squiggles, do they just not want to go there? I don't think so. What we think is failure to establish these feeding sites. So this is a lot of the work that my PhD student, David Gallo, back there is doing. So he is taking a look at the nematode development at the various stages of infection, taking a look at what's going on in the plant from a microscopic perspective, and starting to decipher why these are resistant and why they're not. Other aspect of this, we're taking a look at the root architecture. How does some of these genotypes, how does the root architecture change when we have nematode infection? Is that a potential resistance mechanism? Okay, so then the next one that we're also taking a look at is the genes. That's what I wanted to get at. Which genes are involved in resistance, and can we use that for molecular assisted breeding? And that's kind of where we're going with this. So the third objective of this is actually developing the sweet potato varieties, and I'm sure you heard about that already with Don Labonte. It's basically a national effort. We have the different breeding programs from all around the nation working together to develop these varieties and get them out to you growers. Okay, then the fourth one I'm just going to mention briefly because it's well beyond my expertise, but getting into the physics of how to detect the guava root knot nematode. So at North Carolina State University, they're taking a look at using sensors that we can put out in the field, run through the field, and actually pick up whether they have guava root knot nematode or not. So they're working on that. Other one is on the packing line. Can we use sensors that we can basically detect guava root knot nematode infested sweet potato storage roots as they're coming through the packing line? And the data looks pretty promising from what I've seen from our collaborators. So that's our fourth. Final objective is, of course, the economic analysis and extension. That's what I'm doing here today, engaging with you guys and making sure we get the word out. So recently, just a couple of weeks ago, we launched a website. So Sweet Armor. So if you go to www.sweetarmor.org, it's a fantastic resource. It's got a ton of information about sweet potato in general, guava root knot nematode. Why is it called guava root knot nematode? Different management tactics. Even by state, we have the different nematicides that are registered. You can learn more about our team. We'll do updates. You even see updated events while we advertise this event on the website. So I highly encourage you guys to take a look at our new website. It is going to be a fantastic resource for guava root knot nematode and any root knot nematode management on sweet potato. We also have a Twitter page, so if you're into that, you can follow us on Twitter. And I think that's it for what I wanted to mention to you guys. Okay, well, thank you very much, and I'm going to hand it over to Donnie to talk about some weed science.